Hey, Chem Kids, we're heading back down to the quantum realm to look at the electrons in our atoms. So I want to specifically talk about, let's see if we can get this to move forward, how atomic models can be used to describe and explain the structure of atoms, and more particularly, two models that we have that explain the arrangement of electrons around a nucleus. So this gets really weird. You guys get ready. We're going to start with the Bohr model because that is familiar to us, right? Some of you even drew something like a Bohr model when I asked you to draw an atom. So Niels Bohr, was actually a scientist in the early 20th century. And he studied atomic theory, and he created a model that shows how electrons orbit the nucleus of an atom in energy levels. Okay. And so this should be familiar to you guys. He represented these energy levels as rings around the nucleus, right? So the Bohr model just has these concentric circles with electrons on each circle. Excuse me. So one of the key things to note about Bohr's model and his discovery is that if the electrons live in an energy level that's further away from the nucleus, that means that those electrons living in those further energy levels have more energy than the ones that are closer to the nucleus. Okay. And there is no in between. The electrons are either on one energy level or another. It's like you can't stand between rungs of a ladder, right? You're either on the first rung or the second rung, etc. You can't try to put your foot in between and stay there. That's how electrons are with energy levels around an atom. Okay, there's no in between. They're either on the first or second or third, etc. Something else to be aware of is the energy level only exists if there's an electron in it. Okay, the electron actually creates the shell, creates the energy level. It's not like there's some physical structure there waiting for an electron to occupy it. Okay, the energy levels are created when the electrons go there. Okay, here's a little teaser about something we'll learn a lot more about eventually. The outermost ring, the outermost energy level that has electrons is called the valence shell. Okay, the electrons on this outermost shell are known as valence electrons, and the valence electrons are the ones that are involved in chemical bonding. So when we get to our bonding unit, that's going to become hugely important. Um, all right, so we've been talking about the Bohr model, which really simplifies the way that the electrons arrange themselves around the nucleus of an atom. We're going to compare that to what can be called the quantum mechanical model. Maybe you've heard of quantum mechanics. This is what it's about. It's about the behavior of electrons around the nucleus of an atom. Another name for it maybe sounds simpler, more poetic, is the electron cloud model. And we have touched on that a little bit, but just you wait. It is super bizarre. Check it out. We might even need to do 2 videos to cover all of this. We'll see how we do. All right. So the electron cloud model does include the energy levels. Okay. Bohr recognized that that is a true thing about the way that electrons behave. So the electron cloud model had to incorporate that. It's actually more advanced. And so it includes that. But in the case of the electron cloud model, what we're going to see is that the orbits are not circular. One of the problems with the Bohr model, or inaccuracies with the Bohr model, is that it is two-dimensional. Okay, so the electron cloud model is really trying to give us a three-dimensional model, which, you know, atoms are three-dimensional, so that's going to be a little more scientifically accurate. In the electron cloud model, the electrons are found inside a blurry electron cloud. Okay. The electron cloud is an area where there is a chance of finding an electron. I'm sorry if you can't quite see that at the bottom there, but that's what it says, where there is a chance of finding an electron. So what this means, well, what it does not mean is that the electron cloud is like chock-a-block full of electrons. It's all electrons all the time in there. It's not. Remember how we talked about the fact that if you had a bowling ball proton sitting on the sidewalk downtown, that there would be one penny whizzing around in that space the size of the city? Okay. That's it. It's just the one or, however many electrons the atom has, but they are somewhere in that space. So it's not a really super definitive space. We call it a cloud, and it's kind of fuzzy. All right, let's see. So we are about to come into one of the most important equation in physics and therefore also chemistry. This is the Schrodinger equation. If we can solve this equation, we will know everything about our system, about our atom. In this case, our system is going to be an atom. I think we're almost at 6 minutes. I'm going to pause here, just absorb the looks of this equation, and we'll start here on the next video.